Hey everybody, welcome to today's training. I'm TJ with ShopBot Tools, and today we're going to look at knowing your materials. There are lots of different materials out there. Almost any material can be machined, and it depends on the application, what you're looking to do, for what you may be using that material. For today's purpose of this training, I'm going to look at 5 different types. We're going to look at hardwood softwoods, we'll look at plywood MDF, PVC, acrylic, and some aluminum. So with that being said, we're not limited to those 5 different types of materials. There are lots of different ones out there, but just going to go through this next few slides, some screenshots showing the ShopBot in action, and show you guys a little bit about what bits are used for machining these materials, some things to look out for, and where to locate these materials when it's something that you're looking to cut. For this training, I'm going to reference the router bit starter kit that we sell. You can see it on our website, on our online store, or a lot of you, when you've purchased a machine, have bought this kit. It's 8 different bits that come with the purchase of your machine, and these are just a good selection of bits to get you started. And these bits can be used on a broad range of materials. It's how you program the feeds and speeds for them to cut. So with that also being said, there are hundreds of different bit manufacturers out there, and there's hundreds of different styles and types of bits. But to keep things simple for today's training, I would like to just reference the bits that we stock and that we sell, and these are also the ones that you'll see in your tool database. So that goes into here where the tool database is, which has these 8 different bits that are already programmed into the VCarve software when you purchase your machine. And just a quick screenshot here is showing that each bit has the part number next to its title, and then within the parameters of each bit is where we see our feeds and our speeds. We'll look at different bits that we recommend, up spiral, down spiral, for specific materials, but just a quick overview of what the tool database is showing here for these bits is the spindle speed, which is how fast your router or your spindle is spinning, and that's an RPM, which is revolutions per minute. Feed rate is actually inches per second that we use. This can be changed. Different manufacturers do inches per minute, millimeters a second, millimeters a minute. Here at ShopBot, we do inches per second, and that's how fast the machine is actually cutting. When the bit is down inside your material and it's cutting away the material, that's the speed that the bit is traveling. And in this picture here, you can see it's 2.5 inches per second. Plunge rate also has to do with plunging the bit down into your material. So that's how fast that's plunging the z-axis down. So spindle speed, feed rate, plunge rate, those are 3 things that are going to be something that we'll look at when we set up our bit. I will say these have the starter bit set here has feeds and speeds that are a good starting point. But what we'll look at next is customizing these for your cuts, because again, these bits can all be used for the different materials, but the feed and speed that you apply them to will be a little bit different. So built into your software underneath tools is something called the chip load calculator. And if you click on chip load help here, it does bring up a lot more thorough explanation that you can read more in detail about what I'm saying here, which is just chip load. What we're trying to figure out is feeds and speeds, which is our feed rate we just looked at on the previous slide, which is we do here in inches per second. RPM, which is the number, is the revolutions per minute, how fast that bit is spinning, and then the number of flutes is the cutting edge. You can see that here. That's the edges on the bit, which is typically 1, 2, or sometimes 3 for what we're doing. And then you can see what we're actually trying to figure out here is the physical size of the chip that comes off the cut when we're cutting. And typing things into this calculator here will spit out. These are changeable here, so if you're trying to figure out RPM or speed or chip load, you can change this over here to which one it is that you're looking and hit calculate, and then see if it the number comes out within this range. And you can get more detailed of a chip load calculator if you go to the actual bit manufacturer's website. In this case, Onsrud or Amana are the ones that we're stocking, and you can see that on their websites. But again, the previous slide that showed the tool database, all of those feed rates and speeds are within the ranges here that match this slide. Before we get into the 5 different materials, I just want to make sure we understand the difference between an up spiral and a down spiral bit. So these both here are 1/4 inch cutters that are pictured. One of them has an up spiral, which has the the actual cutting flutes, the cutter's edges spinning in a helix around to the left, where this one goes to the right on the down cut. So you can see on the picture here of a piece of plywood the difference that a down cut on the left or an up cut on the right makes when it's used on plywood, which has a thin veneer on the top. The up spiral actually rips the veneer, especially when you're cutting across the grain, where on the down cut it leaves a nice smooth one. So it is exactly what it's called. An up cut lifts the chips up, which could cause fraying, could cause part lifting if it's a thin material. A down cut is nice because it pushes down so it doesn't rip the veneer. But a down cut, you do want to be careful that you're not drilling using a down cut, because you'd actually be pushing the material down inside of a hole. Let's start out by looking into acrylic. For the acrylic, we actually like to use the 1/4 inch up cut Super O bit. And you can see up top there it has the part number from ShopBot if you're going to order a replacement. That's the Onsrud number, which is the bit manufacturer, and then it has the feeds and speeds. What's nice about using this O flute, it is an up spiral, so it helps get the chips up out of the cut, which gets away the chips from the bit, gets them out of the material, helps keep the bit cool, helps keeps the chips from building up down inside the curve of the cut. And you can see on the bottom diagram there how that it actually cuts away and curls the chips and actually flings them up out of there. So it's a neat cutter for a lot of different types of synthetic materials. So that's the one that we're going to recommend for doing the pocket profile cuts and acrylic materials. And before we look at this bit cutting, here's a few different places for purchasing acrylic. So Piedmont Plastics is one along the East Coast here. We're in Durham, North Carolina, and we use them for a lot of the acrylic material that we use for our different guards and dust shrouds and stuff like that. Sabic is another one that you see on the left. The only thing I want to tell you, if you're going to look into material distributors, a lot of the times these guys are going to want you to buy full 4x8 sheet. Sometimes they're going to want you to have a minimum order. So just check, that's just something. Yellow Pages, Google, plastic suppliers in the area to find those. But I will also point out another place that I use quite a bit, called inventables.com. These guys sell, they even have their own CNC machines that they sell. They have a little bit of everything. But what I like about these guys is I can go onto their website. If I have a specific job where I only need a certain size material, instead of having to buy a full 4x8, I can get, say, a 12-inch by 12-inch piece of clear acrylic, and I can go and order that right from their website. And you pay a little bit more to have it, cut down in size for you, but it's real convenient and nice. So these are a couple different material suppliers. Well, here we can see the bit cutting into a clear piece of acrylic. And what's nice about acrylic, there is no grain pattern that you have to worry about. And you can see that I just ramped that in so that bit didn't jam down inside of the material. Here again you can see the ramp, and you can see tabs being used, and this is a really nice bit for cutting these acrylic pieces. Alright, to summarize the acrylic cutting, yes, the O flute up spiral is the best bit to be used, especially for your profile and your pocket cuts. With that being said, you also can use a V bit when you want to do a V carve, like you can see on the text here for the Erickson guitar and repair. Tip with that is sometimes people they'll run it, and it might be a little bit of fuzzies that get left down inside there. Some people will go ahead and run that file again, and that will clean it out. I personally like to use an air compressor with a real fine tip and blow down into the V carving, and that helps get rid of whatever residues left. Or if you have like a real small scratch all or nail set, you can go down there and scrape it out. But usually it's you have a nice sharp V bit, you can do really good V carving. Same with 3D carving as well. You can see the eagle head here that's held up to the sky, so you can see the light through it. 3D carving is done really well with a ball nose bit in acrylic. A couple other tips is make sure when you're doing your adding a ramp, you're not just jamming that bit down inside there. Acrylic can be real hard, and then to jam that bit down in there, it's not going to get a real good cut. You do not need to worry about the grain direction, as the big sheets of acrylic do not have that in it. And always, again, different brands. There's different. I mean, acrylic. There's hundreds of thousands of different types of composites and different, chemical compositions of all these different plastics. So always, if you're switching to a new manufacturer, it's a first time cut with a piece, test on the scrap piece first before you get into your big carving. Just a little corner of a cutoff, and test your bits and test your feeds and speeds on that scrap piece first. All right, aluminum is one of many non-ferrous metals that you're going to want to cut with your ShopBot. And I got a screenshot right here of a bit from our website. So at the time of this presentation, that bit currently costs $62.25. What's nice about this bit, it is the same one as you saw in the plastic bit. This one just has a little bit different of a actual cutter length. So you can get it with a 3/4 inch cutter length. This one has a 7/8. So again, get into looking at bits. There's different cutter lengths for different applications, but this is a good, all around bit that's good for your wood, aluminum, plastic, solid surface. And you can see here that this one is a little bit slower of a feed rate of 1.5 inches a second, and an RPM at 18,000 RPMs. And also you can see here that this is a 3D carving that was done with an 1/8 inch tapered ball. So again, different bits. This one here is a solid carbide. Again, this is that O-flute for doing your profile and your pocket cuts. And I just wanted to show you too that, using again, tapered ball nose with the same, going in, testing the feed and speeds from the earlier slides, getting your chip load correct. You can use all these different bits that were shown in the previous slides of the starter bit kit from ShopBot. All those different bits can be used on all these different materials. It's the feed and the speed that you set them up when you go to cut out of that tool database. So again, 1/4 inch end mill for doing your profile pocket cutting. And here you can see this is cut, this Indian nickel here was cut with an 1/8 inch tapered ball nose. Aluminum sources, again, you can buy things from Inventables, which was talked about earlier if you just want little sections of instead of full-size materials. Locally here we have something called Dillon Supply. I can drive over there with my truck. I can get a 4-foot by 8-foot sheet of aluminum, and they'll set it right in the back of my truck with the big crane. It's really nice. One thing I really like to do is there's a place here in town, and they're all over the place. I remember these back in Michigan when I lived there, called Padnose was the company there. Down here, here's one just called J&D Recyclers. It's just a mom and pop place here in town where they take scrap metal, but they'll also let you go to their yard and pick out metal. So I could go there and find some scrap pieces of aluminum of whatever thickness or size that I want, and they go up there and they'll weigh it and they'll sell it back to you. So instead of having to buy something brand new or to a certain size, I can actually go and buy some reclaimed aluminum sheet stock to cut. Here we can see an 1/8 inch end mill cutting out the ShopBot logo, and the tube that you see next to the material is something called a cold gun. That's hooked up to an air compressor, and what it's doing is it's constantly blowing cold air on the end of the bit and on the material. And what that's doing is keeping the material from heating up and sticking to the bit. And that's one of the problems, especially cutting plastic and aluminum, is the material will start getting warm, the bit will start getting warm, and the material will just start sticking right to the end of the bit. So that's where that cold gun is on. I took it off for this picture. Again, you can see a little 1/8 inch end mill going down and doing a pocket cut. Again, the thing with the aluminum here is shallow passes. So it's able to move and cut nicely and have a really good feed rate and speed, but we're doing real shallow passes. And then here you can see it doing 3D carving as well. So again, all the different bits in the bit kit are able to do these types of cuts. It's the feed and the speed. You have to set it for aluminum. All right, the key with aluminum is keeping that material, keeping that bit cool. All right, the first thing you can do is a shallow pass. So you're using a small bit, 1/8 inch, say, diameter, 10 thousandths would be a good pass depth, which is 0.01. Sometimes with the larger 1/4 inch bits, we'll go up to 30 thousandths, 0.03 for a pass depth. But it's a lot shallower of a pass depth than you're used to if you're cutting other plastics and wood. So shallow passes. Keep the material and the bit cool. You saw the cold gun in the video. Picture on the bottom right here is also something called a mister, where it mist the lubrication on there. So there's a lot of different types of lubrication that can be sprayed on the bit, sprayed on the material to help keep an oil filament on there to help keep the cutter from getting warm. Also, clearing the chips away is key. That's one thing that's really nice about the cold gun too, is it's constantly blowing, so it's pushing away any of the cut chips. So it helps keep those from getting built up on the bit or in the material. Chip load, again, refer back to one of the earlier slides there. Make sure that your chip load, your feed and speeds are inside of the range. And then again, I'm saying this on every material, but test on a scrap piece. Don't cut into that giant sheet that you just spent a couple $100s on. Test it over on a small piece or on a corner that you're not going to be using in your main project. Alright, let's look into some wood cutting now. And again, I need to point out there are thousands of different species of wood out there. Hardwood, softwoods. Each wood has its own specific characteristic, has just different grain patterns, has different densities. So knowing about your wood that you're going to work with is key. The texture, the grain, the density, like I said. So know your type of wood. And if you don't know anything about the wood that you have, get online and research it. Learn about it. Look at some of the other people. There's lots of forums that you can get a hold of. A ShopBot forum is a key place I would start, and ask other ShopBot operators what they recommend for feeds and speeds. But let's look at setting this up with what we already do know. Again, we'll go back to the up spiral and the down spiral. The video here that we're going to look at is testing the different up cut and down cut bits. I just want to point out, if you're going to be doing any drilling, you want to avoid using a down cut. If you're going to say use a 1/4 inch bit to drill 1/4 inch holes, with a down spiral bit, you're pushing the chips, the sawdust, down inside of that, and that may compact chips in a hole or a groove, and that's not giving any relief for the bit, because there's no place to extract the material. So you're going to build up friction, and you're going to build up heat, which could dull your bit, if not break it. And if you have something like a vacuum hold down in place, you're also going to build up circulating air, which is going to fuel the heat process. So up spiral and down spiral. So hardwoods, softwoods. Again, we can go to anywhere, local lumberyard, Lowe's, Home Depot, and get different types of species. A lot of these have your pine. These are going to have red oak. Some of them may have white oak, but typically red oak. They're going to have some birch. They're going to have some poplar. They're going to have just a few basic types of hardwoods and softwoods. Find a local supplier like we have here in the area called Horizon Forest Products, where they have, maybe 50 different species of hardwoods and softwoods. And then there's other wood specialty stores, say for instance like a Woodcraft, that is going to have more of your exotics and stuff. And just to point out too that all the different bits, again, in this starter kit are able to be used on wood. But when I say wood, I want to say that very loose, very generic, that, again, there's lots of different densities, textures in these different species of wood. So when we go ahead and set up our bit, the same bit can be used for cutting a nice piece of, say, pine versus a piece of white oak, which has different densities, different characteristics that make it that same bit can be used. It's just you may have a little bit of a different feed or speed to set that up. So when cutting wood, there is a good and a bad time to use an upcut or a downcut. So what's nice for upcut is drilling the hole that you just saw there, but you do need to be careful with the upcut when we just did that long cut, which could fray. Now here we're using a downcut, and this is okay using a downcut to drill because it's a hole that's larger than the bit's diameter. And then doing the same cut, because we want to examine the difference here of the up and down cut. And then here's just showing you the down cut going across and with the grain. Multiple passes, but I prefer the down cut when possible, so I'm not going to pull the chip out or rip the outer face that's up. Here, just showing you the tabs to pull them off. Nice tab. Prefer to put the tabs going back and forth with the grain. Makes them real easy to nip. And you can see using the down cut, it does give a nice edge, and it doesn't rip the outer face cut. So you find yourself getting into cutting hardwoods and softwoods. There's lots of different species of wood. So study up on the wood, read up on it, know about the grain. Is it an open grain? Is it a closed grain? The density, how hard of wood it is. That's going to dictate your feeds and your speeds. Once you work on using your chip load calculator to get your feeds and speeds, think about the bit that you're going to use. The upcut and the downcut both had an excellent finish here on this piece of pine that I cut in the example. You can't even see the up or the down difference as far as it ripping the little fibers in the wood. It was real nice. What you do need to look out for is drilling holes, okay? Preferably I like to use an upcut when I'm drilling a hole because you don't want to use a 1/4-inch bit in a 1/4-inch hole. You're pushing with a down spiral, you're pushing it down in, you're going to be compacting the chips. You're not letting it extract the cut wood out of there, the sawdust out of there, so it's going to build up heat, build up friction, dull your bit, and throw off your cut. So ideally it's nice to use an upcut for that. When possible, on a bigger hole like you see in the picture, it was nice to be able to add a ramp to that cut and do a down cut. That way you don't have to worry about it ripping this outer edge. So when I can, I like to use a down cut bit for long profile cuts, pocketing, holes, etc. It all depends on again, the material that you're going to be using. Ramp direction, do watch out with that. It is nice to always add a ramp when you can. Sometimes putting a ramp going cross grain against the grain will rip the fibers out, so you'll want to move your start point in your vectoric software to having the ramp go with the grain. Tab location is the other thing that we saw in the last video. I like to put the tab going back and forth with the grain. It makes it a lot easier to nip out with the utility knife. And again, we've been showing this on every example of different materials, but test it on a scrap piece. Before you get into cutting into the large piece, use a corner of it, scrap piece, extra piece, whatever it may be, but just make sure you test it out first and you're getting the edge quality and the results that you want before you start cutting into your project. Well, let's look at plywood next, and we're really just building on what we just saw with hardwoods and softwoods. Grain direction and that stuff matters just as much in plywood. And the outer veneer has a grain to it, and one is you don't want to use an up spiral, which could rip that veneer, especially cutting across grain. So one thing I just want to point out too, in plywood there is another bit that's added that I really like to use. It's called a compression bit. I wouldn't recommend that for any of you guys that are watching this today who are just getting started. Stick with your straights, your ups and your downs. But once you've really become familiar with your CNC machine, a compression bit is ideal for cutting plywood because it has an up spiral on the bottom and it has a down spiral on the top, and they're built in. Both cutters are built into one bit, and it keeps the outer veneers on both the top and the bottom from ripping. So there's an upcut on plywood, and you can see it's already starting to chip that outer veneer. And watch as we do a cross cut the grain, it just pulls that veneer apart and rips it. Put a down cut bit in and see the difference here in the hole. Now again, down cuts, you want to make sure if you're going to drill with it, it's a bigger hole than the bit diameter. But a down cut does not fray the veneer like the upcut. Let's step back real quick and look at the difference between an upcut and a downcut bit. The ones that we have here in our bit kit, they're both 2 flutes. Now we're not talking about the Super O that we used in our aluminum and our plastic earlier. These are different bits that you'll see in the bit kit and in the tool database. These are 2 flutes. One's an up spiral, one's a down spiral. physically, by looking at the two of them side by side, one has a cutter that has a helix to the left and one has one to the right. So the bits are almost identical, they're just a mirrored image of each other. So it's really hard, is what I'm trying to point out, when you're grabbing one out of your tool bit kit or out of your little bit holder to go, oh, did I grab the up or the down? And you don't want to find that out after you made the cut and go, oh, that was the wrong one. Look what it did to my veneer. And I'm just cut into a $70 sheet of plywood and ripped it up. So the part number is on the side of them. You have to come up with a system that works for you for keeping the up spiral separate from the down spiral, that you put the right one in. And it is important that you grab the right one, because look at the veneer on this upcut. That bit ripped the outer veneer. Being a cheaper outer veneer on that plywood and real thin, it was real easy to tear, especially going against the grain. Using the downcut bit, where it's pushing down as it cuts, it doesn't rip at all, and it gets a good edge quality cut. And you can see it here looking down at it this way as well. So for me, I have a bit holder, tool bit holder that I keep next to my ShopBot, and it says upcut bit V carved down into it, and the other one says downcut. I guess that would come down to the operator, make sure that I put it back in the right location. Otherwise, again, on the shank of it, you'll see the part number, and you can match that with your tool database if it's the part number that goes with the upcut or the downcut. To summarize cutting plywood, bit selection is key. Up spiral, down spiral, we just looked at the difference there. Material selection is big too. The quality of the plywood, the number of plies, how flat a material, the grade, the outer veneers, making sure that you have a good quality piece of plywood. Ramp direction is the same as when we were talking about the hardwoods and softwoods. It's nice to have the ramp go with the outer veneer. If you're cutting with the outer veneer, you'll have less tendency to rip that outer veneer by cross-cutting with the ramp. Tab location, same with the previous example. If you put it to match going back and forth with the grain or with that outer veneer, it's a lot easier to nip out of there. Sometimes it's not always the case where you can put the tabs, but when you can, that's great. And again, always test on a scrap piece. A lot of these plywoods are $40, $50, $100 a sheet, and it's better to test your feeds and your speeds and your bit and how it looks on a little test piece or on a scrap corner of the plywood before you cut into your main piece. Now, PVC has become very popular. It's actually become very affordable lately, and you can get it in different nominal sizes from your Lowe's, Home Depot. You can also get it in sheets as well. I've seen it at Home Depot here in North Carolina, where you can get it in 1/2 inch by 4x8 sheets. We also order it 3/4 inch from some of our plastic suppliers. But just so you guys know, if you're looking to get into PVC, you can't just go to your local lumber supplier and get it. And again, here's that 1/4 inch O flute. We're going back to the O flute bit. So it's an upcut and it's the O flute. And that's a screenshot from our ShopBot store at our current price for it. But I'm pointing this out because right there it shows you the chip load size. It's even giving you a feed rate and an RPM that you can type into your tool database if you have a ShopBot that didn't come with the current tool database that's in the Vectric software. Okay, here we can see the ShopBot machining PVC. The goal of PVC, again, we're back to that super O flute, but what we're looking to do here is not overheat the bit or the material, so that if we do that, it's going to re-weld the chips back into the curve of the cut. So we stick with the O flutes when we're doing profile cuts with this, because it helps get the chips up out of there. It's a nice material, it's great for outside, it has sealed edges on it already. Do remember that it has a cellular core, so when you cut into it, the core of this is a lot more open than the outside faces on it. And you've seen this a few times now already in this tutorial, but test it on a scrap piece. I can't say that enough. Today's tutorial for knowing your materials was a great start. It helped explain the bits, looked into 5 different materials, where to locate them, what bits to use. But if you're going to get into, say, cutting plywood, I would recommend coming to shopbottools.com and viewing some of our tutorials that we have even in more depth. And what we covered today in 20 minutes over 5 different materials, here's different tutorials on each material specific. So cutting plywood, and it goes in more depth about the bits, about calculating the chip load. So I would definitely spend some time going a little bit deeper into your training and into your education of learning about the different types of materials that you're going to cut. We've covered a lot of information in today's tutorial. We've looked at several different types of material. We've looked at the different bits that can be used. A lot of these bits can be used across different types of materials. It's the feed and the speed that you change when cutting these. Remember the chip load calculator that's built into your control software. You can look under the tools menu, pull that down, and there is the chip load calculator. You can also go to our ShopBot webpage and look underneath the training tutorials. There's different tutorials on all these different materials and calculating chip load. Use the router bit starter kit that you can purchase with the ShopBot, and that's got a good selection of 8 different bits that are going to get you doing these different types of cuts with these different types of materials.